All right, so let's look at exercise 2 from section 2.2. So we have this trigonometric or periodic function. First, we're asked for the exact slope of the tangent line. So hopefully this language by now, slope of the tangent line, hopefully by now that's kind of triggering the thought that we need a derivative. So what is the derivative of f? So derivative of cosine of x is negative sine of x, so -3 sine of x. What's the derivative of sine of x? That's cosine, so -2 cosine of x. And then 6 is a constant, so its derivative is 0. So now let's evaluate this function. So f prime of pi over 4. So equals -3 sine of pi over 4 minus 2 cosine pi over 4. So we want to do this exactly. So I am going to avoid using a calculator. Let's figure out what the sine and cosine of these angles are. So quick refresher of, what a sine and cosine, what those things mean. Basically what they mean is this, or one way to interpret them is this. If we look at the unit circle, so circle of radius 1, centered at the origin. Here's what we know. Any point we can think of that has xy coordinates, those are equal to this. The x coordinates equals to the cosine of the angle that projects, this angle theta that sits here. And the y coordinate is equal to sine of theta. So another way to look at this is I want to know what the x and y coordinate are for this point here, given that this angle is pi over 4, or in degrees, 45 degrees. So let's try to start labeling the sides of this triangle. One thing I know is this, unit circle. So this radius has to be 1. So I am drawing this point from the origin of my graph to the circumference of my circle. All right, so we know this radius is 1. Something else we can rely on is the fact that we know this is a 45-degree angle, this theta, which means that so is this angle. That tells us that these two sides of this triangle are equal. So if I use Pythagorean theorem, a squared plus b squared equals c squared, I can make some simplifications here. I can say a squared plus a squared equals 1 squared. So 2a squared equals 1, a squared equals 1/2. Finally, a equals 1 over radical 2. So again, the two sides of this triangle are the same. So this tells me what? This tells me that the cosine of pi over 4 is 1 over radical 2, and the sine of pi over 4 is 1 over radical 2. So you may have gotten to these two conclusions a lot earlier than I did, but I think it's worthwhile to see a refresher on, some of the way these trig things are structured, especially sine and cosine, and everything else is kind of based on them. But they all kind of come back to this idea of the unit circle, especially cosine and sine. Now that we have that information, we can drop these values in. -3 times 1 over radical 2 minus 2 times 1 over radical 2. So all told, the exact slope of the tangent line here is going to be -5 over radical 2. All right, moving on to part B. Okay, now I don't want to find the slope of the tangent line. I want to find the full equation of the tangent line. So I still need the derivative, so let's write that down again. F prime of x equals -3 sine of x minus 2 cosine of x. And I want to evaluate that at x equals pi. So -3 sine of pi minus 2 cosine of pi let's look at the unit circle again. So the angles around here are going to be 0, pi over 2, pi, 3 pi over 2, and then one full rotation is 2 pi. So where on the unit circle am I looking? I am looking straight left. So on the, where the unit circle crosses the negative portion of the x-axis. So if this is a circle of radius 1, I'm not going to redraw this, ignore how out of scale and asymmetrical it is. What point is this on the unit circle? This is going to be x value of -1, y value of 0. So this means that cosine of pi is -1 and sine of pi is 0. So -3 times 0 minus 2 times -1. The slope of my tangent line is 2. But I need to find the full equation. So let's do this in point slope form, and then we'll manipulate it to look like slope intercept form. So y minus y1 equals m times x minus x1. Do I have values for y1 and x1? At this point, I don't think I do. So let's get those. What is f of, well, I have x1. I guess that's pi. But what is f of pi? F of pi is going to be 3 cosine pi minus 2 sine pi plus 6. What is cosine of pi? That's -1. So 3 times -1 minus 2 times 0 plus 6. So all told, that's y equals 3. So now I have values for x1, y1, and m. So y minus 3 equals 2 times x minus pi. So y minus 3 equals 2x minus 2 pi. Move some things around, and I get y equals 2x minus 2 pi plus 3. So that is a good equation for our tangent line. Moving on to part C. All right, at the point where a equals pi over 2, is f increasing, decreasing, or neither? Again, we've done so many things with derivatives. Hopefully by now you'll recognize that determining the behavior of a function, whether it's growing, shrinking, that comes from the derivative. So I want to find the derivative, which I'll just write down because we've already found it a couple of times. -3 sine of x minus 2 cosine of x, and I want to evaluate that at pi over 2. So f prime of pi over 2 is equal to -3 sine pi over 2 minus 2 cosine pi over 2. Okay, let's draw another bad unit circle. And we'll remind ourselves where pi over 2 is. That's probably the least bad one I've drawn so far. Pi over 2 is here. So what are the x coordinate and y coordinate of this point here? That should be x equals 0, y equals 1. So the value of this derivative here should be -3 times the y coordinate, which is 1, minus 2 times the x coordinate, which is 0. So that'll be -3. That's less than 0. So what does that mean about my function? It is decreasing. All right, finally, part D. All right, at the point where a equals 3 pi over 2, does the tangent line to y equal f of x lie above the curve, below the curve, or neither? How can we figure that out without even graphing the function of the tangent line? Okay, so this last question kind of gives us some guardrails. I don't want to graph the function. So I don't really want to think about what's going on, around 3 pi over 2. I probably need, I could probably figure out what the value of this function is at 3 pi over 2, but I don't want to graph it. And I don't need to graph the tangent line. So I don't really even need the first derivative. So what I'm really asking for is this. I have one of two options here, or at least There are probably others, but it's implying to me that one of these things happens. So I have a curve that looks like this, where the curve is below the tangent line, or how does it word it? Sorry, is the tangent line above the curve, or is the tangent line below the curve? So what's the difference between these two curves? Probably lots, but the one that's most relevant to what we're doing here is that in this case, or on the left-hand side here, this curve is concave down. And on the right-hand side, this curve is concave up. So in order to answer this, let's look at what, actually, there's one more thing we should look at here. I'm assuming a positive tangent line. Does it matter if my slope is, or my tangent line is negative? So I have a negative slope here. What if the curve is still below the tangent line? I still think that's concave down. Okay. So I don't think it matters what the value of the tangent or the slope of the tangent line is, but I'm glad that I looked at that contingency. So because of that, I think we can look directly at what the value of the second derivative is. So how do we get there? We have to go to the first derivative. So I'll write that down yet again. -3 sine of x minus 2 cosine of x. And then we'll take the derivative of the derivative to get f double prime of x. So it'll be -3 cosine of x plus 2 sine of x. And what's the point we care about? 3 pi over 2. All right. I've had a lot of practice. I'm going to draw a good unit circle now. Not so. Here we go. So 3 pi over 2. We have another quadrant angle. Those are much simpler to pin down where the coordinates of x and y are. On the y-axis, so x is 0, and on the negative y-axis, so y will be -1. So if I want to evaluate the second derivative here, mean -3 cosine of 3 pi over 2 plus 2 sine of 3 pi over 2. So the cosine of this angle will be the x value, so -3 times 0. And the y value will be -1, so plus 2 times -1. So all told, I get a value of -2. So that's less than 0. So what does it mean when the second derivative is less than 0? That means we are concave down. Okay, we're almost there. We were asked, does the tangent line lie above the curve, below the curve, or neither? Hopefully from my diagrams, you can see why I'm saying that concave down implies that the tangent line lies above the curve. And really, these two things are, I believe, equivalent to each other. If you have a graph that's concave down at a point, then that means the tangent line has to be above the curve at that point.